Today's stuff, we're doing Chapter 5, Section 4. It's the slope formula. So up until now, for slope, we've been doing like rise over run, or change in y over change in x. And we've never really done like the actual equation, which is generally as you move on in math. So geometry, algebra 2, pre-calc, you're going to just use the slope equation. So the old way of doing it, so far we've been saying slope is rise over run or change in y over change in x if you're looking at a graph. Fair enough? So this section here we finally get the equation to get the 2 points. So example 1, if we have the slope from 2 points, so slope from 2 points. I'm going to try to kind of derive the equation or get the equation from what we've been doing before. So I'm going to take and make a graph. And if I have my first point kind of being here somewhere, I'm going to call it the point 2, 3. And then if I go over and to the right, make it look kind of believable. I have a point over there, and I'm going to write 7, 12. That's my other one. So I have these 2 points, 2, 3, and 7, 12. And up until now, if we're trying to find the slope between these 2 points, you could even, if you wanted to, try to put a line between the 2 points. We've been saying, well, if you take and turn this into like a right triangle, something like this here, then we have the rise being this side, or the change in y, and the run being the horizontal part on the bottom. And we could go through and figure out, well, how much does it go side to side? How much does it go up and down? Well, in doing that, this here, do you agree, this is going to be my 2 in the first point? And then this here is going to be my 7 in our second point. If we go back to that first point on the y value, this should be a height of 3. This one here should be a height of 12. Might be a little high on my graph, but something like that. So if we wanted to look at the rise, we could have before like counted up on the graph and seen how much we're going up. But if we're going from a 3 to a 12, how much do we go up? 9. How do you get 9 from a 3 and a 12? 12 minus 3, or subtract 3 from 12. So really when we're doing rise over run, you could say rise over run. We're just taking like one of the y values and subtracting the other y value from it. This is probably the point where I should write this in. What they do is, if you want to have an equation, they put in variables, because then the variables will work for any number. So instead of saying that my rise is going to be 12 minus 3, I'm going to take and label my points this way. That lower point, I'm going to call it x sub 1 comma y sub 1. And really it's kind of like when we were doing sequences and we had like a sub 1 or a sub 2 or a sub 3, saying like the first a or the second a, the first term or the second term. This is saying the first x value and the first y value. Then up here my 7 and my 12 would be x sub 2 and y sub 2. And those 2's, it's not saying 2 times x or x squared, it's just saying the second x. So instead of writing 12 minus 3, do you agree we could say it'd be y2 minus y1? And we could do that same thing then if we were trying to figure out, well, how much do we go to the side here? What was our run? We could say 7 minus 2, but that's really saying my 7 is just my x2 value, if you're looking right there. So instead of 7, we could say the second x, so x sub 2 minus the 2, that one there, which would be x sub 1.
Would that be like y1 minus y2?
Okay. I mean, quick finish. So this here is going to equal m. They use a lowercase letter m to stand for slope. And then I'll do slope. Equals slope. So I'd take that and put that in a big old box or draw an arrow to it, but that's really if you get that, that's the point of the section. That's the point of the section. Josiah asked an awesome question. He said, could you take and get the exact same thing, so could you also, and I probably wouldn't write this, but could you say slope is y1 minus y2 over x1 minus x2? You're going to get the exact same answer. So it doesn't matter if we do, for this one here, we could do 12 minus 3 over, so we did this one minus that one, divided by, if you started with the 12, then you just have to start with the 7. So 7 minus 2 for my x's. So now I have a change of 9 over 5. If we do those in the other order, it's still going to work. But if we have a 3 minus 12, so that'd be if we did it like this, the y1 down here, what am I trying to do? So if we did this point minus that point, we'd have 3 minus 12 divided by, but then we have to start with the 2. So 2 minus 7 for our second one. 2 minus 7. So it looks like we're going to get a different answer because we have a negative 9 over a negative 5. But if you have a negative over a negative, the negatives cancel. And once we simplify that negative 9 over negative 5, we get that same answer. So as long as you always start with the same point. So if you're going to do the second point first, if you're going to do 12 minus 3, then you have to do 7 minus 2. You might want to consider putting something like, you must start subtraction with the same point. It's totally up to you if you want to, but you must start the subtraction with the same point. Often what I'll do is I'll look at it and I'll do the big number. I'll start with a point that has the bigger numbers so I can stay in the positives. But the most common mistake is I'll see people do like 12 minus 3 and then they'll do over 2 minus 7 or something like that. And you always, if you start with the 12, you have to start with the 7 in the denominator. You start with the 3 in the numerator, you have to start with the 2 in the denominator. So. Example 2. Example 2 would be slope from a graph. So slope from a graph. And let me quick throw a graph paper thing in there. So if we were to take and maybe even do something like this here. So if you have something like this, what I would do is I'd take, if you have a line on a graph, you're trying to figure out slope, look for a spot where it looks like it nicely crosses a point that you can find. So there's one. It looks like another one's going to be here. So I'm going to go with those 2 points. And first for that first one, the upper left, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be a negative 9 for an x value and a y value of 1. And then my other point that will be a little less counting, it's negative what?
2.
Comma. Negative 3. Negative 2, negative 3. Do you want to start with that point that's on top or the point that's on the bottom? I don't care. Bottom? Bottom works for me. So I'm going to say m equals y2 minus y1. What I probably will do is on your next test, I'll ask you to know this equation here from memory. I'll give you a half sheet of paper, ask you to write it from memory, and then I'll give you you turn in that half sheet, then I'll give you the equation for the rest of the test. So if you forget it, you lose half point, maybe a point, but you don't bomb the test. Until you get good, you guys said start with the upper one, didn't you? So start with the lower one? Okay. If you said start with the lower one, we'll call this one my x2 and my y2. Until you get good, or if you find you're making mistakes, I think somebody said they wanted to start there. Oops, got that wrong. Until you get good, you might want to consider labeling your points x1, y1, and x2, y2. It just makes it you're less likely to make mistakes. Because now you just plug and chug. I have y2 minus y1, so y2 is negative 3. Minus y1, that's a positive 1. Over x2, that's a negative 2. Minus x1 is a negative 9. So then I have negative 3 minus 1 is negative 4. Over negative 2 minus a negative 9 is really negative 2, 7. Negative 2 plus 9, so a 7. Can I reduce my 4 over 7? Nope. So final answer then is going to be negative 4 over 7. So if you get a question, here's a line on a graph, find 2 points on the line, get the slope from those 2 points. Good? I suppose you could go back and find the 2 points and then do the rise over run if you wanted to. We went down 4 to get here to here, and over 7. You could do it that way as well, I suppose, from a graph. One more example, and then we're done. So example 3 is the slope from an equation, or finding the slope given an equation or something. The slope from an equation. And for that, basically, we know how to get the slope from 2 points, right? So if you have an equation, just find 2 points, and then get the slope from those 2 points. So I'm going to say find 2 points. And calculate slope with the equation. And actually later on in Algebra 2, maybe later on this year, you'll get some shortcuts for this type of equation or other types of equation. But if I have an 8x minus 4y equals 16. So this kind of ties into what we were doing, I think, in section 1. The easiest points, I think, to find are going to be the intercepts. So if I first find the y-intercept, so where does it cross the y-axis? So x is 0. And if we do that, you can say, well, right here, 8 times 0 is 0, so that just kind of drops out. Negative 4y equals 16, so y has to be negative 4. Nice. So negative 4. So we have 1 point. My next point, I'll put a 0 in for y, just because that's easier than putting in other values for y. So now I have a minus 4 times 0, so that just drops out. We have a minus 0. So 8x equals 16. X has to be 2. And I'll maybe say x1, y1, x2, y2. Try to model that whole labeling them. But if you were to your homework tonight, if you go through and label this stuff, so if you actually write out this equation before you do the homework, you're going to be more likely to get it right, and then come test time when it's like, oh, tomorrow you're going to have to write that from memory, so you're going to know it cold. So I just get in the habit of doing that until you get comfortable with it. So I have 0 for y2 minus a negative 4 over x2, so that's a 2, minus x1, that's a 0. So what do I get? Numerator becomes 0 minus a negative 4. Yeah, positive 4. Because when you do minus a negative, it changes it into addition, right? So positive 4 over 2 minus 0, which is 2. And 4 over 2 equals? 2. 2 or 2 over 1, I suppose, for slope, but 2.